So with our power modules, you need a input cap, an output cap, a resistor divider, done.
Hi, it's Eamon with ipXchange. We're at the TDK booth. I'm here talking to Tony because I spotted some oranges. I love oranges. And that struck me as quite strange for a power show. So, Tony, what's going on in this booth?
Well, Dr. Standing, thank you for interviewing me. Basically, I work for TDK's micro point of load group, which is a chip-embedded power module. And as you look down here, what we focus on is power density. So this is the latest and greatest on achieving the highest level of power density of chip-embedded power modules for DC to DC.
Nice.
Now, normally, where you'll find these parts is in areas where they need compute density. Artificial intelligence, real-time processing, video, robotics.
Cool.
So over here, as you mentioned, the oranges and tomatoes, this actually is an end product by one of our end customers. This end customer is called Labforge. This is an AI camera, and this particular chipset of this AI camera is using a very modern processor from Toshiba called the Toshiba Visconti. And you can see here it's about the size, not much larger than a euro or Canadian quarter. And our market point of load is actually supplying the power density around the processor. So essentially what we enable is size and mobility in an AI camera. And this is the actual AI camera working here. And it actually has two lenses. And it's actually transporting real-time video recognizing fruits to 100 gigabit Ethernet into the cloud.
Nice.
Yeah, so this software that was written by Labforge was designed using an AI algorithm to recognize fruits, but you could train it to recognize about anything. Planes, automobiles, animals, pedestrians, cars.
Nice.
In this case, they're recognizing tomatoes when they're ripe, so it's actually showing the actual percentage that it's actually a tomato. And of course, if it's red, it's more likely ripe. And it's actually doing it real time. You can actually see, as you look at the video there, the idea is that it's some kind of truck or loader or factory automation, and it's sensing the tomato, and then some kind of automated process to pick up the tomatoes as an example.
Oh, cool.
So the whole point here is power density, compute density, enabling technologies, artificial intelligence, a lot of cool stuff.
Incredible. So what kind of technology is this? Is this normal silicon? Is it silicon carbide? Is it GaN? Or just normal?
Good question. So the first thing in order to achieve this is design simplicity. So we use a single die.
Oh, okay.
And this single die actually contains the DC to DC regulator, the upper layer MOSFET, the driver. It even has advanced functions to do telemetry.
So this is really integrated.
It's really integrated, yeah, single die. And then this die is kind of sandwiched into something we call TDK C-sub technology, which stands for semiconductor in substrate. But in that process, we also added heat sink. So as you make things smaller, if you kind of feel this, it's kind of hot.
Oh, yeah.
So the heat is dissipating into the actual metal because the power comes out from the middle of the package.
Nice.
So the heat sink's connected to the hottest section of the die, it's routed to the bottom, and it flows out of the board. That means no airflow, which means more advanced design as well. So when you do power density, you have to find a way to solve out to bring out the heat out of it as well. So that's the advantage of this technology.
Oh, excellent.
Yep.
So our audience is primarily design engineers. So if a design engineer was looking to test this out, is there an evaluation board or anything?
There is. In fact, at this QR code here and on this website, you can actually scan that. And what it is basically is a website that has our complete design files.
Oh, sweet. Okay.
Schematics, layout files. You could literally design in 24 hours with what's on this website.
Cool.
So speed of design is the other thing we focused on with this module. In fact, this module is so simple, I have a cheerleading routine for it if you're ready for it.
Oh, yeah. Go on. Go on.
So with our power modules, you need an input cap, an output cap, a resistor divider, Done.
Sweet. So,
That's it.
So 3 components, basically.
Basically 3 major components and you're done. So it's very highly integrated, which is the whole point of power density.
Well, fantastic. I'm speechless, to be honest. I'll ask my stock question that I ask at the end of these interviews. How are you finding PCIM?
I think it's a great conference to talk to power engineers, especially at the system level,
Yeah.
because we're offering something different at the system level. DC to DC has been something that's been up for years.
Of course.
But what's happening is compute density is getting to a new level. There's basically no more space on the board. And with mobility and AI, everything's got to be smaller, compact, efficient, and easy to design in. So that's the next generation and that's why we're here at PCIM.
Cool.
I do have one more sensor here I wanted to show you. That's for the elderly.
Oh, okay.
And it's not a live demo, but this is a radar sensor
Okay.
developed to sense when a senior citizen falls in their care home room.
Okay.
So the idea here is senior citizen, everybody wants privacy.
Yeah.
So how do you detect if someone falls and then provide emergency to that elderly person as fast as possible? So what I found out was from this particular customer who's called Gold Sentinel,
Okay.
they actually have this in 10 beta sites in Canada of care homes where they're actually sensing the elderly falling. And it's using a 77 gigahertz radar sensor from
Okay.
Infineon.
Okay.
And they're actually using our power for the radar sensor, the Ethernet, and the controller. But the whole point of their intellectual property is the AI algorithm that actually senses when a person falls at a very high rate.
Okay.
They're now investing in also the way that they walk to also sense if there's something wrong.
Okay.
And this whole idea here is to save lives and for better what we call medical wellness.
Yeah.
And another example, now if you look inside of it, you can actually see the actual module. So Dr. Standing, it's got a power Ethernet, a 48 to 12 volt supply, the radar sensor, and inside here is our power on the other side.
Okay.
Now this entire unit was the first version. The whole entire thing is going to shrink. And what's really cool about the product is called Elephase. Apparently, when I talked to the CEO of the company, a fantastic group out there, a guy named Chris Lehman, Elephase was called for this product because elephants really take care of their young. And it's just a creature in the world that really cares about things. So the whole idea behind this product, Elephase and Gold Sentinel, was products with AI to really bring something new to the world of IoT and AI with our power density as well.
Cool.
So this is a fantastic product. I thought I'd show that here.
Nice. Oh, thank you very much. Well, that was extremely unexpected at the Power Show. So thank you so much, Tony.
Okay, Dr.
This
Standing.
is really good. And thank you for
Appreciate that.
flattering me with Dr. Standing.
No problem.
So, how do you get me attracted to a stand? An orange, because I hardly ever get to eat them when we're at a trip. I wasn't expecting to see an AI demo at PCIM, and I wasn't expecting to see a power module that small, which allows for such high compute density in a product. It was also really, really cool to see multiple end products where a device had been used effectively. It really, really illustrates what's possible, and frankly, I was blown away by that interview, and all it took was some fruit on the stand.
Aren't you going to tell people to go to the ipXchange website?
Yes, and I'm also going to tell you to eat more fruit. It's good for you, and so is visiting the ipXchange website.